Okay, I'm going to test this out and see if I am recording. I'm going to be going over the multiple choice part of your solubility test in just a few minutes. Hey guys, this is the video that I promised you that we would go over. I may have to put this in 2 videos because I have another meeting here in just a second, but we're going to go over the multiple choice questions. What I expect you to write down in terms of your my brain is having a hard time thinking right now. In terms of your test corrections are not only what I go over, but if there's additional information that can help you solve a problem, because I may not give you everything that you need to completely correct that particular question. I may just lead you to a point where you would have enough information to continue on. Okay, so this is not going to be an all-inclusive. Here's how you do it. You should write down just this because you guys are AP kids, and at this point you should be able to think for yourselves. So this is just designed to help you, not do the work for you. So let's look at the first question that we have here. The very first multiple choice question. If you missed this one, then you'll need to correct it. In a saturated solution of zinc hydroxide at 25 degrees Celsius, the value of the hydroxide ion is known. What's the value of the solubility product constant for zinc hydroxide? Well, one of the things as you're going through this, that how I know that you're practicing and working these problems is I would see things written on your multiple choice part. So to correct this, you're going to need to actually write out your equation for zinc hydroxide. So we have zinc plus 2 OH ions. And then you need to write your KSP expressions. KSP is equal to zinc times OH squared. Okay, so we know the value of the hydroxide ion concentration is the number that I circled or underlined. What is the value of KSP? If you know this one, you also know the zinc, but since they're reacting or they're breaking apart in a 1-to-2 ratio, then you have to assume that the zinc is half as much as the hydroxide because you're only getting one of the zinc ions for every 2 hydroxide ions. So if I half 2 times 10 to the negative 6, that would be 1 times 10 to the negative 6. And then in this spot, I'm going to plug in 2 times 10 to the negative 6. You can't forget to square that. Okay, so now I can do the math without a calculator on this one. If I square 2, that's 4. If I square something that has an exponent, I'm just doubling that, so times 10 to the negative 12. And then I'm still multiplying times 1 times 10 to the negative 6. And so 1 times 4 is 4. And add your exponents times 10 to the negative 18. So the correct answer in this one was A, right? So you're working out these problems, showing where you solved it so that I can see you understand what you're doing now. All right, let's look at the second question. How many moles of NaF must be dissolved in 1 liter of saturated solution of PbF2 at 25 degrees Celsius to reduce the lead to 1 times 10 to the negative 6? And then they give you the KSP value. All right, again, we're going to draw out our dissociation. So we have lead plus 2 fluoride ions. And then I want to see your KSP. KSP equals lead, times F minus and squared. Okay, those are always the first 2 things that you should show, and I expect to see on any of these solubility problems. All right, so we know lead is this amount, right? Okay, so on this one, your job is to find out how much NaF. Well, what's the common ion here? That would be F minus, okay, in NaF. So we don't care about the Na, it's a spectator ion here. We have the KSP, so we just plug that in, 4 times 10 to the negative 8 equals. We know that the Pb is, we're trying to reduce it to this amount, so we'll go ahead and just plug that amount in. And we're trying to find this value. So I'm just simply going to call that F, I guess, F minus, but that could be your X, and then it's also squared. So technically, and it's not 2x squared here, it's just simply you're trying to find this number, all right? It's not like you're solving for solubility. You just simply want to know what is F minus at this point. So I'm going to divide by 1 times 10 to the negative 6. And when I divide 4 by 1, that's a 4. And then when I divide, also remember I'm subtracting exponents. So a negative 8 minus a negative 6 would simply be negative 2. So 4 times 10 to the negative 2 is equal to the concentration of F minus squared. But I need just F minus. So I'm going to take the square root of this. And when I take the square root of 4, that's 2. And then whenever I'm taking the square root, literally I'm halving that number, right? So that would be 2 times 10 to the negative 1. And that's your F minus amount right there. So we look up here and we find 2 times 10 to the negative 1. And that would correspond to the correct answer of C in that one. Okay, let's look at number 3. Number 3, we have a problem where we're looking at this equation and we're looking at this equation. And this goes back to some skills from the very first time we talked about equilibrium, right? You have an equation and then it says what is going to represent the equation that looks very similar to that one, but you notice some differences. Number 1, you see that the exponents, like the CL, has a 1, understood 1 in front of it, but the CL here has a half. So this top equation has been multiplied by 1/2, okay? Or you could say it's been divided by 2. Also notice that the HCl is on the opposite side, so it's been flipped. Okay, so in order to find the K for a flipped reaction, we would take the inverse of K, right? So we could eliminate B out of there since it's not an inverse. And we would also want to, since we've got to multiply by an integer, you multiply your K by that same integer, which would be to the 1/2 power. And something to the 1/2 power is the same as taking the square root of that. So actually, I forgot to get rid of D there. So we're left with the correct answer of C for that question. C is the same thing as 1 divided by K to the 1/2 power. Pause the video anytime you need to go ahead and record your answers, and then make sure you go back and add some actual understanding. Like, give me a couple of sentences showing that you understood what we just did here. Don't just assume that writing everything down that I write down is all you need to have. Okay, I want to see that you actually understand what you're doing. All right, number 4. The solubility of CuI is 2 times 10 to the negative 6 molar. What is the solubility product constant for CuI, the KSP for CuI? So again, we're going to write CuI breaks down into Cu. Now, notice this one's only a positive 1 because iodine is a negative 1. And so if I did my little reverse crisscross, then copper has to be a positive 1. That is a possible charge for copper. It can be a positive 1 or a positive 2. All right, and it says the solubility. Now, if you remember the little thing, solubility is my X. On Valentine's Day, hopefully none of you are having to worry about an X. And you have a sweetheart, maybe, or if you don't, that's awesome. You don't have to worry about spending all your money on them. Okay, so solubility is your X. Therefore, this is the X value. So I'm simply just going to plug it into my KSP that I'm about to write. Cu positive, I minus, and that's the X. So this would normally be an X, 2 times 10 to the negative 6. And this is an X, 2 times 10 to the negative 6. And I let you guys use a calculator on this, but we could do this without a calculator pretty quickly. If you just multiply 2 times 2 is 4, okay, and then add your exponents. So times 10 to the negative 12. Here's your answer. So we look over here and we get the correct answer of C, number 4. After solving that through, I need to put my equal signs here, kind of finish this problem through here. All right, number 5. This is simply a definition. And if you miss number 5, you need to study what exactly is equilibrium. I'm going to throw this question on here on your test until people do not miss this question anymore. It is too easy. What is equilibrium? Equilibrium is simply when the rates of the forward and reverse reactions are equal. That's it. The chemical reaction is still happening. It's going forward and it's going backwards, okay? The concentration of reactants and products might be equal, maybe they're not. It just simply depends on the ratios in your stoichiometry. So that's not true. That might have been, I think, probably the most common one that I saw people put down. But it's when the rates of the forward and the reverse reactions become equal. Look that definition up in your book and write down the page number if you missed that question, okay? That is your job. All right, number 6. What is the molar solubility in water of silver chromate? I'm going to check the time real quick. I have a conference at 11. The molar solubility of water for silver chromate. So we're going to go ahead and draw this out. Ag2CrO4. Break it down into 2 silvers with a charge of a positive 1 plus CrO4, 2 negative. All right, and then let's write our KSP expression. KSP equals silver positive squared chromate. Okay, there we go. If you're putting a plus sign right there, you need a spanking on your hand. No, 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 no. In fact, if you look at your open response questions, I put a lot of question marks on, like, what is this? Remember that old thing they used to do a few years ago? What are those? Well, that's what I'm asking. What is this? Why are you putting a plus sign in between there? Okay, because those things are always multiplied in your K expression. Do not be tempted. I'm going to be like, what is that? Can't even talk. All right, here we go. The KSP we have is this number. So that goes right there. We're going to plug it in, 8 times 10 to the negative 12. And then this value is going to be 2x. And here's a mistake I see. It's 2x inside the brackets or parentheses with a square on the outside. Over here, this is x. So 2x squared would be 4x squared times an x, which will end up being 4x cubed. Okay, 4x cubed. So to solve for this, we would need to divide both sides by 4. 8 divided by 4 is, running out of room over here, is 2, right? And 2 times 10 to the negative 12, but that's still equal to x cubed. Okay, so in order for us to find this, we would need to take the cube root of both sides. And they didn't even ask you to do that, even though I let you use a calculator on this. So the correct answer for this one is D, because we had to divide by 4 to get that one. All right, moving on to the next question. All right, number 7. It's a little tricky one. When I worked this one out, I'm like, this doesn't even have a correct answer. Because in order to compare these substances, you have to solve down to solubility. For instance, we can compare lead chromate to manganese sulfide because both of them have 2 ions, right? So those two could be compared to one another. We could compare lead hydroxide and zinc hydroxide to each other, not to everything else, but because those two have 3 ions. But we can't compare them all to each other in order to come up with an answer. So let's see if we can figure out just a couple of things here. All right, so lead chromate. Look at its KSP value. Look at manganese sulfide. The one that would have the lowest solubility in water between those two would be the lead chromate, okay? It has a lower solubility than the manganese sulfide. So that in and of itself would actually eliminate A. It says lead chromate and the other two have higher solubilities. No, it has a lower solubility than manganese sulfide. And then let's look at another one. It says on D, lead chromate has the highest molar solubility in water. Actually, manganese sulfide has a higher solubility than lead chromate, so we could get rid of D. All right, then let's look at the other two. We have zinc hydroxide and we have lead hydroxide. It says zinc hydroxide has the lowest solubility in water. We actually don't know which one has the lowest solubility based on this until we calculate solubility, okay? So if we look at lead hydroxide has the lowest molar solubility in water. Again, we're going to have to calculate the solubility. Solubility is your X, okay? So let's do that real quickly. And with the lead chromate, you've only got 2 ions. I'm doing this with a calculator. I guess I can do this without a calculator because I'm going to take the square root of that, but I don't know what the square root of 2 is. So let's do this in the calculator. If I take the square root of my number is 2 times 10 to the negative 16. 16. Okay, so I get 1.4 times 10 to the negative 8 for that one. I'm just going to write that out right here. That's its solubility, lead chromate. All right, I'm going to do the manganese sulfide because that one's easy too. So take the square root of that one, and 2.3 times 10 to the negative 13. And that one happens to be 4.8 times 10 to the negative 7. Okay. Now, the other two that we're asked about were zinc hydroxide and lead hydroxide. So remember with these, you've got 3 ions. And so not only will you have to you'll actually have to divide by 4 and take the cube root like we did on that last problem because it had 3 ions. So let me go ahead and punch that in. 1.2 times 10 to the negative 15 divided by 4. And then I'm going to take my cube root. So I need to hit my math button, and 4 of that number, okay? And I get 6.7 times 10 to the negative 6 for that one. Do the same thing with the zinc hydroxide. So 4.5 times 10 to the negative 17th divided by 4. And then I'm going to take the cube root. Oops, not second. I just need to hit math. 4. Grab that number, and I get 2.2 times 10 to the negative 6. Now we can look at numbers. Okay, who has the lowest solubility? Looks like lead chromate, according to the numbers, has the lowest solubility. So B and C are not the answers. Neither one of those are the answers. But I threw this question out, but I do want to see all of your solubilities calculated, okay? Now, I went through that really quickly. I want you to actually go through and write out the expressions for these. Write the equation first and then write the KSP expression and show how you calculated the molar solubility. That's good practice for you. All right, I got to check the time because my appointment's coming up. I'm going to try to get through the multiple choice, though, before I go. All right, number 8, we have some PbCl3 and Cl2 are mixed in a container at 200 degrees Celsius, and the system reaches equilibrium according to the equation above. Which of the following causes an increase in the number of moles of PCl5 present at equilibrium? Okay, so we want to push the reaction to this side, right? If we decrease the volume of the container, well, that'll work if, well, it'll shift it. Just depends on looking at our moles of gas. You've got 2 moles of gas on this side, and on this side you only have 1 mole of gas. When you decrease the volume, you're squeezing the container, right? So you're squishing it. And so which side doesn't need as much room? That's right, the side with PCl5 doesn't need as much room. So we want to push it to that side because we're trying to produce more PCl5. So A would be the correct answer on that one. Let's just look at the other choices. If we raise the temperature, increase it, okay, remember putting it that way would actually cause the reaction to shift to the left, so that's not it. And remember that adding a mole of any noble gas never does anything. If we raise the temperature and add a mole, well, that's just a combination of B and C, which we already decided wasn't going to work anyway. All right, moving on to number 9. After the equilibrium represented above is established, some pure O2 is injected into the reaction vessel. So equilibrium has been established, so we're now going to inject some O2, and a new equilibrium will be re-established. Okay, it says, which of the following has a lower value compared to its value at the original equilibrium? A says KEQ for the reaction. Remember, the only thing that changes K is temperature, and we did not change temperature, so A is not a choice. The total pressure, that's a tricky one because you just put some O2 in there, right? And it shifted the reaction to this side. And you're like, oh, well, that should be lower because it went to less moles. But do you know how much O2 you put in there? You don't. You could have like flooded the system, used up pretty much all of the SO2, but still had a ton of O2 in there. And so we don't know if the total pressure in the reaction vessel was lower than its original amount, just because you don't know how much O2 is in there, okay? The amount of SO3 in the reaction vessel. Well, when we put O2 in there, it shifted the reaction to the left. So that would actually go up, not down. We're looking for a decrease. And then the last one says the amount of SO2, there's a 2, in the reaction vessel. Well, so if we put more O2, that's going to go down because the reaction is shifting to the left, and D is going to be our choice. All right, last question on multiple choice. Precipitates are insoluble ionic solid products of a reaction in which certain cations and anions combine in an aqueous solution. The determining factors in the formation of a precipitate can vary. Which of the following leads to the formation of a precipitate? All right, one of the things that you need to remember is in these precipitation reactions, you have a solid, you spell this correctly, salt, and it breaks down into ions. So you have cations and you have anions. And each one of these are aqueous, right? That's what's happening in this reaction. So in order to form a precipitate, you have to shift to this side of the reaction. That's where your solid is. That's your precipitate. So if you're shifting to that side, let's think of our little number line where we do Q and K, all right? I'm always going to shift to reach K. Where would K have to be to form a precipitate? K is going to have to be on this side if I'm shifting to form a precipitate. It means Q would be over here. Okay, so to form a precipitate, Q has to be greater than K. So let's look at our options here. Q is not equal to K. Q is not less than K. Q has to be greater than K. Q equals 1, yeah, that's not ever going to happen on this type of question because you'd have to have a K to actually compare that to. All right, that's the end of the multiple choice. I will come back to you and probably do a different video. So you'll have 2 videos that you'll have to click on in order to get the rest of this. Okay, I have to go to my meeting and I will see you guys in just a little while.